Something invisible is dragging us through space at 1.4 million miles per hour. It is hidden behind the thickest part of our own Milky Way, buried in a blind spot so dense that no optical telescope has ever seen through it. 40 years later, they still do not know what it is. In 1987, 7 astronomers found something the sky had no business doing. Working from ground observatories around the world, they tracked more than 400 galaxies and found that not one or two, but all of them were leaning the same way, tracking relentlessly toward one fixed patch of sky at the same speed. These were whole galaxies getting dragged offline, big ones, entire collections of billions of stars, all being pulled off the course that the expanding universe predicted. They called themselves the 7 Samurai, and the number they measured changed the field overnight. 627 kilometers per second, 1.4 million miles per hour, fast enough to cross the United States in 8 seconds. Whatever sat in the dark out there possessed enough gravity to bend the path of every galaxy in our neighborhood. The 7 Samurai gave it a name. They called it the Great Attractor. Are we being pulled forward by something massive, or shoved from behind by nothing at all? 3 separate teams spent 40 years screaming at each other over the math. A few weeks ago, one of them broke the models entirely. That number is not the shaky part of this story. We know it from the oldest light in the universe, a faint glow left over from the Big Bang that fills every direction in space. In the early 1990s, a satellite called COBE mapped that glow across the entire sky and found a bruise in it. One side slightly warmer, the other slightly cooler. That bruise tells us we are moving, and it confirmed what the 7 Samurai found from the ground. Our local group of galaxies is heading toward one patch of sky near the constellations Norma and Centaurus, roughly 200 million light-years away. That kind of steady drift does not happen by accident. Something with real mass was doing it. And it was not just us. Whole neighborhoods of galaxies were caught in the same current, hundreds of thousands of them, all flowing the same direction, at a speed no known structure at the time could explain. But the 7 Samurai had a problem that would haunt every team after them. The patch of sky where all those galaxies were heading sits directly behind the densest part of our own Milky Way. Billions of foreground stars, thick clouds of dust, bright lanes of gas stretching across thousands of light years. Invisible light, that entire direction is practically blank. Astronomers call this blind spot the zone of avoidance. It hides about 1/10 of the sky, and the Great Attractor sits behind the worst part of it. For the first decade after the Great Attractor was named, the investigation was nearly impossible. We had the vector. We had the math. But trying to look at the target was like staring into high beams. Every time someone pointed an optical telescope that way, all they saw was the Milky Way staring back at them. The problem was simple. The Milky Way was in the way. And it was not a small obstacle. The zone of avoidance is not a pinhole. It is a wall stretching from horizon to horizon in the southern sky, and the Great Attractor sits squarely behind its thickest section. This is the part of the Milky Way where the star fields are so dense that background objects vanish completely. Even nearby galaxies disappear behind it. For decades, the most important region in our cosmic neighborhood was the one place we could not look. Astronomers had a direction, a speed, and a name for the thing causing both. What they did not have was a single photograph of the suspect. So they switched tools. Visible light got blocked by dust. Radio got through. In the mid-2000s, the Parkes Radio Telescope in Australia began sweeping the zone of avoidance. Hydrogen gives off a radio signal dust cannot block, so Parkes went looking with that instead. Billions of light years of debris lay between source and receiver, and the signal arrives clean. When Parkes looked through the blind spot, hidden galaxies lit up immediately. Hundreds of them, sitting behind the curtain, invisible to every telescope that relied on ordinary light, quietly drifting in the same flow the Seven Samurai measured 2 decades earlier. The zone of avoidance was not empty, it was full. We just could not see it until we changed how we were looking. And once we could see, the investigation moved fast. At the same time, X-ray telescopes picked up something different. Galaxy clusters contain gas heated to tens of millions of degrees, and that superheated gas glows in X-rays. X-rays cut through dust the same way radio does. An X-ray telescope in orbit scanned the zone of avoidance in the direction of the Great Attractor and found an unmistakable signature. A massive cluster of galaxies, blazing with hot gas, sitting almost exactly where the trail pointed. That cluster is called the Norma cluster. It is anchored at the heart of a wall of galaxies stretching across tens of millions of light years. It was enormous, and until then, ordinary telescopes had missed all of it. Models put its mass at roughly 1 quadrillion suns. Thousands of individual galaxies, gravitationally bound together, concentrated in the exact region where 400 galaxies said the pull was coming from. The cluster that nobody could photograph was finally on the map. For the first time, they had a real suspect. A hidden city of galaxies, massive enough to bend the motion of everything nearby, sitting precisely where the math predicted. After 2 decades of measuring a pull they could not explain and staring at a blank patch of sky they could not see through, the investigation finally had something to point at. And for a minute, it looked like the case was over. The Norma cluster was a massive find, but it utterly failed to close the math. When you add up every galaxy in Norma, every cloud of superheated gas, every estimate of dark matter holding the structure together, the total falls short. Badly. 627 kilometers per second across 200 million light-years of space demands more gravity than Norma can produce on its own. The cluster is enormous by any normal measure. 1,000 trillion suns is not a small amount of mass. But the motion we measured requires something on a completely different scale. The pull was too strong for the suspect they found. Something else had to be contributing, something larger, something further out. And the question of what that something was broke the investigation wide open. That is where the case split into 3 camps. The first camp said Norma was only the center of it. Not just one cluster, the whole neighborhood around it. The Hydra Centaurus supercluster, long chains of galaxies winding through the cosmic web. And then there was the part nobody could see, the dark matter between those clusters. That was how the first camp tried to make the math work. For 15 years, they swore this hidden empire explained everything until the evidence tore their map in half. New X-ray data reaching deeper through the zone of avoidance produced a revised mass estimate that was devastating for the first camp. The Great Attractor region appeared far less massive than the original models predicted. The first camp had overestimated, possibly by a large factor, how much matter was actually sitting behind the curtain. And the trail did not stop at Norma. It kept going. 650 million light-years further out, past everything the first camp had mapped, past structures they had not even cataloged, sat one of the most massive collections of galaxies in the nearby universe, the Shapley supercluster. Thousands of galaxies packed into a volume of space that dwarfs the entire Great Attractor zone. The flow of galaxies did not converge on Norma and stop. It streamed right through and kept heading outward, toward Shapley, as if Norma were not even the main event. Then the second camp came in and wrecked that theory. The Great Attractor was never the final destination. It was a speed bump on a much longer highway. Norma happened to sit between us and the real source of the pull, like blaming the nearest hill for a river when the mountain range sits 10 miles behind it. The galaxies flowing past the Great Attractor region did not slow down. They did not cluster there. They kept right on going. And there was a second piece of evidence that made the case worse for the first camp. The Great Attractor itself appeared to be moving. The whole Norma region, along with everything around it, was streaming toward Shapley. The first suspect was not just too small. It was also a victim, caught in the same current as everyone else, being dragged in the same direction by the same unseen force. But the second camp had the same gap the first camp had. Even adding Shapley, the math could not close. The direction was off by dozens of degrees. The total pull still came up short. 627 kilometers per second remained stubbornly unexplained. Neither camp could close the case. The math would not cooperate, so the third one stopped asking the same question. For 40 years, every team asked the same question. What massive structure is pulling us? That was the only question anyone thought to ask. Gravity pulls. Things move toward mass. Find the mass and explain the motion. It seemed obvious. In 2017, Yehuda Hoffman stopped looking forward and looked backward. His team had been reconstructing the full three-dimensional flow of galaxies across hundreds of millions of light-years. Every push and every pull mapped together for the first time. Most researchers focused on the heavy regions, the clusters and superclusters where galaxies pile up. Hoffman focused on the gaps. And inside that reconstruction, something unexpected appeared. A void. Not a small gap between galaxy clusters. A region of space so enormous and so empty that it was not just sitting there passively. It was actively shoving galaxies away from it. Hoffman's team called it the dipole repeller. The dipole repeller sits roughly 500 million light-years behind us, opposite the direction of the Great Attractor. When one side of the map has far less mass, galaxies fall away from it faster, and that acceleration adds directly to the motion we measure from Earth. It is not a subtle effect. Hoffman's reconstruction showed the dipole repeller contributing a significant fraction of our total velocity, pushing us away from a region where the universe is thinner than almost anywhere else in our cosmic neighborhood. Put the pull in front, together with the push behind, and you get a current. That current is what we are riding. Scientists call it the dark flow. 1.4 million miles per hour was never a simple pull. It was always a tug of war, dense structure dragging from the front, an enormous void shoving from the back. Our galaxy caught between them. Everyone had spent 40 years looking out the windshield for whatever was dragging us. It took 4 decades for anyone to check the rearview mirror. 40 years of framing the Great Attractor as a single force pulling us forward. Half the answer turned out to be coming from behind. And nobody had even looked for it until 2017. Every model, every paper, every documentary about this subject had assumed the same thing. Something big is pulling. Find the big thing. Hoffman asked what happens if the emptiness behind us is just as important as the mass in front of us. The answer reshaped the entire investigation. This is the point where the old explanation starts to crack. The real motion of our galaxy is not one hand pulling. It is gravity and emptiness working together, mass and void, shaping a dark flow across the largest distances we can measure. The Great Attractor, the name that was supposed to explain everything, only covers one side of the equation. The textbook version of this story, the one that says a single hidden structure is dragging us forward, was never the full picture. It was the best guess anyone could make with incomplete data from a partially blind sky. And incomplete is exactly what it turned out to be. Even with the dipole repeller added to the picture, the full 627 kilometers per second could not be closed. A gap remained. A significant one. The pull and the push together got closer to the answer, but they did not finish it. Filling that gap required tools no previous team had built. In January of 2026, Richard Stiskalick's team published the most detailed reconstruction of the local universe to date. They built the sharpest local map anyone has had, using real survey data from thousands of nearby galaxies within 500 million light-years. Older models gave the outline. This one tried to measure the pull piece by piece, running the physics forward and backward in time. It is still a model, but it is the best local map we have had. And it came back with bad news for the old story. The Great Attractor, the classical version that has appeared in every textbook and every documentary for 40 years, is a ghost in a snapshot. Stiskelec showed that if you freeze galaxy motions at one instant and trace where the flow lines converge, they point at a spot near the Norma region. It looks like a single attractor. Run the clock forward and those flow lines scatter. The convergence drifts. The pattern dissolves. Freeze the picture, and it looks like everything is heading for one spot. Let it move, and that illusion falls apart. And the numbers backed it up. The total mass within 500 million light-years of us accounts for only about 72% of our speed. That means nearly a third of the force pushing and pulling our galaxy comes from somewhere we have not fully identified. The remaining 28% comes from structures further out or from motions we have not fully mapped. The direction does not align either. There is a 38-degree gap between where the local mass says we should be heading and where we are actually going. That is not a rounding error. That is a mismatch large enough to tell us the map is still wrong. The Norma region falls short. Shapley falls short. The dipole repeller fills part of the remainder but leaves the rest open. When Stiskelec ran the simulation billions of years into the future, the dominant pull on our galaxy was not toward the Great Attractor at all. It was toward the Virgo cluster, our nearest massive neighbor at 65 million light-years. That was the structure with the strongest long-term gravitational hold on our local group. Even Virgo only accounts for about a third of our current speed. The rest is distributed across so many sources that no single one of them controls the outcome. After 40 years of hunting, was the Great Attractor even real? Or have we been chasing a ghost? Yes and no. Make no mistake, Norma actually exists. It is a genuine, massive cluster of matter burning hot in the X-ray data. But the idea that one single Great Attractor explains why we are moving at 1.4 million miles per hour, that is the ghost. Our motion is the product of competing forces pulling from the front, pushing from behind, tugging from the sides, with no single structure in charge. The name stuck. The explanation behind it did not. Now there is a claim repeated in every comment section, every social media thread, and nearly every other video on this subject. The Great Attractor is a supermassive black hole swallowing galaxies like a drain at the bottom of a sink. That is wrong. It is not one monster sitting out there. It is a region of galaxy clusters and dark matter stretched across tens of millions of light-years. No single black hole produces that kind of distributed gravity. The name fools people. It sounds like one thing. It is not. It is the shape of the mass around us, doing what gravity does over a very long time. And here is the part almost nobody mentions. We will never get there. 200 million light-years. At 1.4 million miles per hour, that crossing would take well over 100 billion years. The universe itself is only 13.8 billion years old. Our sun burns out in about 5 billion years. The Earth will be unrecognizable long before that. Every human being alive today, every civilization that might come after, will be gone before our galaxy covers even a small fraction of the distance to the Great Attractor region. This is not a problem we can engineer around. It is not a question of building faster ships or waiting long enough. The universe will not allow it. But the distance is not the real barrier. The real barrier is dark energy, the force accelerating the expansion of space itself. Right now, gravity is still strong enough locally to hold groups of galaxies together. The larger river of galaxies around us, LANIAKEA, still has a shape for now. But LANIAKEA is not permanent. It is a temporary eddy in a river that is speeding up. Over billions of years, the expansion compounds. The distances between galaxy clusters grow wider, the pull weakens, and eventually, dark energy wins. Shapley drifts beyond our gravitational reach. The dipole repeller recedes into the expanding dark. The Great Attractor region gets carried away until its gravity can no longer touch us. One by one, the galaxy clusters that defined our supercluster will pass beyond the cosmic horizon. Their light will stretch and fade. The flow of galaxies that defined LANIAKEA will break apart. And what remains is our local group. The Milky Way and Andromeda, merged into one galaxy after their collision roughly 4.5 billion years from now, will be surrounded by a handful of small companions. Everything beyond that will have vanished from view. The night sky of that distant future will contain only the stars of our own galaxy. Every other light in the universe will have gone dark. We are not racing toward one final place. The whole map is shifting while we move, and we are still missing pieces. About a decade ago, astronomers pulled a new suspect out of the zone of avoidance. A hidden supercluster called Vela, buried in the dust of the southern sky, was completely absent from every previous map of our cosmic neighborhood. Nobody had factored it in. Nobody had even known it was there. It had been exerting gravity on us, contributing to the drift, warping the flow around it. And every model built before its discovery was missing that input entirely. Early mass estimates suggest Vela may rival the Shapley supercluster, which would make it one of the heaviest gravitational players within reach of our local group. If that holds, the gravity math we spent 40 years building needs to be redrawn from scratch. Every few years, the map gets redrawn again. And the list of suspects is getting longer, not shorter. The zone of avoidance is still giving up its secrets, one frequency at a time. So here we are, moving at 1.4 million miles per hour, caught between forces we spent 40 years misreading, inside a supercluster that will not last, with new suspects still emerging from a blind spot in our own sky that covers 1/10 of everything we can see. After 4 decades, the question that started this investigation is still open. Which team got it right? The first investigators who said the Norma region explains the pull, the second camp who said Shapley is the real force behind the motion, or the 2026 team who says no single structure matters and that the Great Attractor we named was a ghost in a snapshot. The evidence is in front of you. Pick your side. Tell me why in the comments. Because the next video on this channel covers something that makes the Great Attractor look gentle. A dead star, 20 kilometers wide, with a magnetic field 1,000 trillion times stronger than Earth. One crack on its surface releases more energy in 1/10 of a second than our sun produces in 100,000 years. That is what we do here. We pursue the cases that look impossible until you lay the evidence out. If that is the kind of investigation you did not know you were looking for, subscribe. We go further every week.